And welcome back. As we continue our programming journey, we are going to continue working at how late binding affects things, particularly by looking at this concept known as downcasting and upcasting. So last time we left off with our toString method and how that kind of affected our code a little bit. So let's go ahead and look at the following code. So we have sale variable, discount variable equals new discount sale, paint 1510, sale variable equals discount variable, system out print line sale variable dot toString, and of course right there is our toString that we are very familiar with now. So an object of the derived class discount sale is also the type of its base class sale, and so you can assign it to a variable of the base type. And so we can see that right here because we have sale variable is equal to discount variable. Now if we look at this invocation of toString up here, remember this is going to be a invocation that is going to use our late binding, because the invocation sale variable dot toString uses the definition of the method toString that's given in the class discount sale. Now that means that the output of the code is going to be paint price is equal to 15.0, discount equals 10%, total cost is 13.5. Because we are using late binding again here, the meaning of the method toString is determined by the object that has been created, not by the type of the variable. Alright, so just a nice good recap here. We're using the objects to really kind of determine what is going to be the appropriate toString that's been used. Now you might ask, why would you ever want to assign a type discount sale to a variable type sale? Well, we make such assignments actually a lot more often than you may think, but they tend to happen kind of more behind the scenes, and so you don't necessarily notice these things happening. So when we peel behind the curtain, like let's just say we have a parameter that's really just a local variable, and every time you use an argument of type discount sale for a parameter type sale, we're actually assigning an object of type discount sale to that of a variable of type sale. So for example, consider the following invocation taken from the definition of the copying constructor for discount sale. Super original object. This invocation original object is actually of type discount sale, but the super is the copy constructor for the base class sale. Therefore, the super has a parameter of type sale, which is a local variable of type sale that is set equal to the argument original object of type discount sale. So what does that mean? Well, how does this start working with things? So we start looking at how our definitions get determined here. The things you have to note is that the type of the variable naming an object determines which method name can be used in an invocation with that calling object. However, the object itself always determines the meaning of a method invocation performed by an object, and that's what we mean when we talk about late binding. Again, a lot of the stuff we've already talked about, we've already kind of covered here in some of these, but it's always good to kind of bring things all together. The type of a class variable determines which method names can be used with the variable, but the object named by the variable determines the definition of the method name that is used. Now there is a special case of this rule, and the special case is the type of a class parameter determines which method names can be used with the parameter, but the argument determines which definition of the method name is used. So just keep that in mind. Now we did talk about downcasting and upcasting at the very beginning here, and this is a term that we haven't really defined, so let's take a look at how that kind of relates back in. Well, assigning an object of a derived class to a variable of a base type, or really any ancestor class, is what's known as upcasting, because it is like a type cast to the type of the base class. So when we look at our inheritance diagram, remember that base classes are drawn above that of derived class, because derived classes are spawned below. Now when you do a typecast from a base class to a derived class, so that'd be like sale going to discount sale, or any ancestor class or any descendant class, this is what's known as a downcast. Now upcasting is pretty straightforward. There's nothing really we have to worry about with implementation or anything like that, and Java's going to pretty much just handle them appropriately, so you don't have to really worry about any kind of special clauses. However, downcasting, there's a little bit of things that we have to look at in order to make it work properly. So with downcasting, let's look at an example here. Now this is very similar to what we saw earlier, but there's going to be a slight change here. So we have sale variable equals new sale paint 15, discount variable, and they say discount variable equals discount sale in parentheses, so we're typecasting this, sale variable. This will give us an error because we notice we're trying to go from the derived class here to the base class, all right, because sale variable is of type sale. In this example, the downcast does not make sense because the object named by the sale variable has no instance variable named discount, and so cannot be of type discount. We think about every discount sale is a sale, but not every sale is of discount sale, as we've seen above. Now, it's therefore false to us as the programmer to use downcasting only in situations where it makes sense. If it doesn't make sense to do it, well, then avoid it. Now, downcasting, of course, can lead to errors, as we just saw here. It's key to note that, our discount variable equals discount sale variable produces a runtime error. However, if you put it into your program, it's not necessarily going to give you a compile error. And that's very interesting to note because while, if we look at this one, discount variable equals sale variable, this is actually going to get us a compile error. All right, so not every error is going to be the same with discount or with downcasting here. Java does its best to try and catch these downcasting errors as soon as it can, which some of it's going to be at compile, some will be when you actually run your code, depending on how it actually is used. Now, downcasting does have some necessity. There are times when we do need to use downcasting. And while it does have drawbacks, for example, there's things like when we define an equals method for a class that we may end up needing it. Now, note the line from our definition of equals in the class sale. We say sale of the sale is equal to sale of an object. And of course, sale is a typecast here. This is a downcast from the type object to the type sale. Remember, object is a class. It's really the big base class that we all refer back to. Without this downcast, however, though, the instance variable's name and price in the return statement reproduced as below would be illegal because the class object doesn't have instance variable. So we say name, dot equals of the sale dot name, and price equals of the sale dot price. So it wouldn't work if we had just couldn't do that with type object. Now, of course, as we mentioned, there are errors we can run to, but there's also pitfalls that we have to kind of be aware of. So as we already mentioned, only use this when it makes sense. All right, that's the first thing to remember. Only use this when it makes sense. The compiler is not going to necessarily make a check to see if the downcast is reasonable or not. Because, remember, when we look at those errors, the two places they're going to show up will probably be if it's a compile error or if it's going to be a runtime error. However, if we use downcasting in a situation where it does not make sense, we're usually going to get a runtime error message. So we do get that. So that's kind of nice that we can still get some kind of feedback that, hey, this is going to cause trouble. Now, the instance of operator is a great way to test whether or not downcasting is sensible, because sometimes we don't know. Maybe it's a little confusing, or does it actually make sense? Well, downcasting is, it's going to go to a specific type. And that type has to be reasonable whether the object being cast is an instance of the type, which exactly is what instance of operation is going to test for. The instance of operator checks whether an object is of the type given as the second argument, and the syntax is simply just object instance of class name, which returns true as the object of a type class name. Otherwise, it's coming back false. So, for example, the following would return true if some object is of type discount sale, some object instance of discount sale. So, a quick tip here, we want to check to see whether downcasting is legitimate, and the way we do that is noting that first that because every object of every descendant class of discount sale is also of type discount sale, well, that expression would be returning true if some object is of any descendant class of discount sale as well. So let's just look at this here. If we say we want to typecast to discount sale, we can then make the cast a little bit safer with our downcast by doing the following. Discount sale ds equals new discount sale, and we say if some object, the instance of discount sale, ds is equal to discount sale, some object. You notice we have our typecast right there. System.println, ds was changed to some object, else system.println, ds was not changed. And of course, that's just, again, using this instance of operator here to test to make sure that we can actually use that safely with our downcasting. And of course, if we look at this, some object might be, for example, a variable of type sale or of type object, and that would be an example when we want to use that downcasting within our code.